Welcome to the Unit 7 review on polynomials. This review consists of 12 multiple choice problems followed by 9 free response problems. We have the introduction to polynomials, multiplying, and these are topics we've done earlier in the year, so I'm not going to discuss too much. Factoring polynomials, factoring based on conjugate pairs, and factoring trinomials, and further work on factoring trinomials. So basically, this unit is concentrating on factoring things. Don't forget you could always review the lessons at emathinstruction.com, and it's time to get started. As we begin, our first problem is quite easy. You can use a calculator if you want to, but you should not need one in any way. We have to find the solution to 4x cubed plus 2x squared plus 3x plus 7 when we input x equals 10. So what we're looking at is mathematically doing 4 times 10 to the third power, adding to that 2 times 10 squared, and adding to that 3 times 10, and finally adding on a 7. So the first part is 4,000, because 10 to the third power is simply a 1 with 3 zeros. Then we have 200, we have 30, we have 7. And so our final choice of solution is choice 3, 4,237. In problem number 2, we have to just identify. We're not solving anything. We just have to identify which thing here is a polynomial expression. And all polynomial expressions have the following form, and this was put up in class. Ax to the power of n, whatever that is. Then the next one would be b times x to one lower power, right? And cx to the n minus 2. And this goes on until we finally get to some constant. Okay? Of all these things, the only thing that fits that setup is choice 2, where we have x to the second power, followed by x to the first, followed by a constant. Problem number 3, we have to add polynomials here. I like to align them so that I have the like terms all in the same column. And now I can just add straight up. It doesn't matter for this whether you go left or right. So I have 10x to the second power. Remember, you don't add exponential terms. Those are considered like terms. So you just keep them as is. Now I have 3 x's, and finally I have minus 2. And so the best choice here is choice 1. Problem number 4, we're asked to find the product of these two terms, and remember, you have to recognize the word product means multiply. So what we have to do is multiply negative 2x to the third power times this other term, which is a binomial. It's called binomial because it has two things in it. And we have to distribute our negative 2x cubed across the binomial. So as we do that, the first product we get is negative 8x to the fifth. Remember, when you multiply exponents, what you do is just add up the exponential value. Now I'm going to do negative 2x to the third times negative 2. So negative times negative is a positive. 2 times 2 is 4. And we're left with this, and our best choice is choice 4. Problem number 5 is asking you to consider an actual rectangle. It might be helpful to sketch one down and just write the values for its length and its width. I like to consider this bottom portion the length and this the width. It doesn't matter because at the end of the day, what you're doing to find area is to multiply the length times the width. So we're going to be doing FOIL, which looks like x plus 8 times 2x plus 3, and we go first with first. That's 2x squared. Outside terms, 3x. inside terms, 16x, and the last with the last gives us the 24. When you do FOIL, the outer and inner terms always give you like terms here in the middle, so our final solution is 2x squared plus 19x plus 24, and our choice is choice 3. Problem number 6 is asking you to know what squaring means. So we're going to take our x minus 4 and we're going to set it up as something to be squared. And then you want to expand that. Don't be lazy, because you will miss stuff. When you expand it, again, we're going to apply that idea of FOIL. And we're going to have x squared. Outsides are negative 4x. Insides are negative 4x. And last with last is 16. Again, combine your like terms in the middle. That gives me x squared, that's an equals, minus 8x. These don't cancel out, they're both negatives, plus 16, and so the choice for number 3 is choice 4. Problem number 7 gives us two pairs of binomials that we have to FOIL and then combine. We have our first pair of binomials up front there, and the second pair immediately behind here. So we have to do each of them, because multiplying is always done before you do any addition. So let's do that. So we're going to do x plus 5 times x minus 5. And I'm applying FOIL. So first, outsides, inside products, last with last, and I get all that. Now I have to add to that these products here. X squared, outers, negative 2x, insides, positive 2x, and last with last. Insides, last with last. Now that I have it here, all I have to do is combine like terms. And some things will cancel out immediately. For instance, this negative 5x and this positive 5x are gone because they're opposites. So are these 2x and negative 2x terms here. So what we're left with is x squared plus x squared. Well, that's 2 x squareds. And negative 25 and negative 4 makes negative 29. And so our choice is choice 1. Problem number 8 asks to find the GCF, greatest common factor, of these binomials. So what I want to do, unless you're really good at this, is you want to expand them out. So I'm going to write one on top of the other so you can see how everything matches up. So I'm setting it up here, and I'm going to expand each one. Now when I factor the numbers, I want to bring them down to primes. In other words, 10 is 2 times 5. Those are prime numbers. I have 2 x's, and I have 5 y's. Below that, 15 can be factored down to 3 times 5. 1x and 3 y's. So I'm looking to make matches to get that greatest common factor. And the key word here is common, right? What's in common? Well, I have a 5, I have an x, and I have 3 y's that all partner up. And so our greatest common factor is 5 times x times y to the 3rd power. That is choice 4. Problem number 9 asks us to identify which of these products are incorrect. And in order to check that without actually factoring, we can simply multiply these things back together and see if we get back to what we were starting with. 10 times x cubed gives us 10x cubed, And when we do this, we get 10 times 4x is 40x. So this is correct. 5x squared times 2x would be 10x cubed. That works. 5 times x squared times 8 is 40x squared. Oh, hold on. That's no good, right? 10x cubed plus 40x squared is not what we have here. So that's simply found already. The choice is choice 2. 2 is the one that's incorrect. Number 10, which of the following is not a factor of 7x squared minus 28x? So first we're going to pull out our GCFs. I'm going to write it this way right now. So that would be 7 times x, and this one, 28, factors down into 7 times 4 times another x. I can see here that one common thing that they have is the 7. Another common thing they have is an x. So if I were to factor this, honestly, I would pull out the 7x. But I'm looking at my choices here, and I see that my factors are, we have a 7, there's an x, and don't forget there was a minus in between here, and there's also an x minus 4. Looking at my choices, I see that the best choice is choice 4, because we're looking for the one that is not a factor. This is, this is, this is. Number 11. We are factoring a binomial that is actually what's called the difference. Difference means subtraction. This is the difference of two squares. So when you factor the difference of two squares, it takes on a very predictable pattern. So x squared minus 64, notice there is no middle term here. There's no x term. So we're going to just break it down into our factor parentheses. And we think what goes up front, because remember, we're like sort of undoing FOIL. Right? Something foiled and made this. So let's think backwards. What times what makes x squared? X times x makes x squared. Now this is a perfect square, right? That's because the square root of 64 is 8. So I know that 8 times 8, 8 times 8 makes 64. So I'll put the 8's in. Now I just have to consider the signs. And since there is no middle x term in my problem here, I also know that one has to be positive and one has to be negative. And you can FOIL that back to double check. And notice how the product of the inner terms is 8x, but the product of the outer terms is negative 8x. And so they're going to cancel each other out. So our final choice here is choice 2. Problem number 12 is referring to 2x squared minus 3x minus 20. So in this case, our trinomial, which is in the form of ax squared plus bx plus c, right? We actually have an a that is greater than 1. In this case, it's a 2. So I like to factor using a method called payback. You use payback when the front coefficient, when a is greater than a 1. The way this works, let me set up my problem. I have 2x squared minus 3x minus 20. And I want to do a sort of illegal math operation for the moment. I'm going to take the 2, the front number, multiply it to the back one. And I'm going to rewrite that. So the 2 is now gone, and I have x squared minus 3x, but now it's minus 40. This is easy to factor. So I'm going to set up my pairs of parentheses. And again, I'm undoing FOIL. And I know that the front term should both be x, because x times x makes x squared. Now, to decide the last pair of values here, I have to think of a pair of numbers that multiply to equal that negative 40. And they have to add to equal that middle term, the negative 3. So I can sit here and write out combinations, or I can think about it a little bit. 40 could be 4 times 10. Will that somehow give me a 3? No. Let's try some other things. 2 times 20? No. Let's see, I'm going through my thoughts. 4 times 10? No. 2 times 20? No. How about 5 times 8? Well, that's interesting because I see here the difference between these two numbers is a 3. They're 3 apart. So I'm going to use that combination. I'm going to put 5 and 8. The order doesn't matter. And now I have to decide the signs. Since they add to negative 3, that means that the 8 must be negative and the 5 must be positive, because positive 5 times negative 8 does make that last thing. And the product of my inner terms and my outer terms should equal our middle term in that trinomial, and it does. I see that that is 3x negative. So I know that's the correct thing. So answering this question, the correct choice is, oh, sorry, I didn't pay back my 2. Common mistake. Don't forget to pay back. I almost forgot. I would have chosen the wrong answer. So I have my factors there. Let me pay back that 2. I'm going to use red. That means I'm going to stick the 2 right in here in front and in front. Okay? I can stop right now. I see that one of my factors is 2x plus 5, and that is choice 1. My other factor, remember you would always want to simplify this. My other factor would be x minus 4. That's not here anyway. So the correct choice is choice 1. We're now into our free response section. This is where you must show your work all steps of the way. Our first problem asks us to find the difference between these two polynomials. And when we're finding difference, that should trigger your mind to think about subtraction. So we're going to subtract the second thing from the first thing. So I'm looking at negative 5x squared plus 3x plus 8. And I'm going to subtract from this the 2x squared plus 4x plus 1. But let's remember that there is an invisible 1 there. And when we're subtracting, subtraction, I'm going to write it for you, subtraction is the same thing as adding the opposite. So we can change a subtraction problem into addition. What this ends up looking like is negative 5x squared plus 3x plus 8. But now instead of this positive 2x squared, I'm going to change it to minus 2x squared. And I'm going to reverse all the signs. And now all I have to do is combine like terms. Remember, things with exponents, you don't alter them. So negative 5x squared and negative 2x squared altogether is negative 7x squared. Positive 3x We're now into our free response section where we have to show all our work. Remember that in this first problem, since it says difference, we should be thinking about subtraction. And we're subtracting this polynomial from this one. So what it looks like is 2x squared plus 4x plus 1 minus all of this one. But I want to remind you something very important. When you are doing subtraction, subtraction is the same thing as adding all the opposites. In other words, consider over here in front of this subtraction portion of the problem, there's actually like a 1 in front of there maybe. In which case, when you distribute that negative 1 across the board, you're flipping all the signs. So now I'm looking at 2x squared plus 4x plus 1 plus 5x squared minus 3x minus 8. Now all we have to do is combine our like terms. And remember that when you're adding exponential terms that are alike, you don't alter the power there. Leave the exponent alone. We're just combining like terms. So combine our like terms. In which case we're looking at over here 2x squared plus 5x squared, which is 7x squared. Here are our two x terms, a positive 4x minus 3x leaves 1. And finally, the positive 1 and the negative 8 is negative 7. Problem 14 consists of 3 parts. In part A, we have to first find the product of this binomial pair, this pair of binomials, and we want to represent it as a trinomial. Well, that naturally comes to be, so don't let that stress you out. What we want to do is apply our FOIL. We want to multiply. So x plus 2 times x plus 3 produces first with first, outsides are 3x, insides are 2x, and last with last is 6. And again, there are our like terms. So we have x squared plus 5x plus 6. Part B says test the equivalency of your expression with the value 4. So let's see that it works out. So we're doing a test. We're comparing our answer here to the original problem to see that they both produce the same answer. So starting with the x plus 2, or the original problem, I'm going to plug in 4. And now I have 4 plus 2 and 4 plus 3, which is 6 times 7. And I get 42. Now I'm going to check my trinomial, which was x squared plus 5x plus 6. And the idea here is, if done correctly, I should get the same answer. So I'm looking at 4 squared plus 5 times 4 plus 6, 16 plus 20 plus 6 also equals 42. So here I've just done my test, and I'm testing the equivalency of both expressions. In part C, we have to explain how the expression in part A can help you quickly find the product of 12 and 13. Okay, well, in the expression x plus 2 times x plus 3, let's consider this. If x were to equal 10, then this x plus 2 would be 12. And this x plus 3 would be 13. Since we know that x plus 2 times x plus 3 is the same thing as this trinomial, and I know now that this is 12 times 13, then this trinomial must also equal 12 times 13, because they're equal things, in which case this all equals 156. Right? So we can quickly get to a product of a trinomial. In this case, if we go backwards to the binomial, we can show how, if we try a 10 to make it 12 and 13, why? Because that's what they were talking about. We can then jump, instead of evaluating this trinomial, by getting this, we know they're the same. We can get the answer. Here we're asked to find the product of 3 things, not just 2. So FOIL is not really going to be the straightforward response here. We have to show our steps as we work our way through this. So when you have 3 things, you want to first, you can only handle 2 at a time. So what you want to do is work the first 2 first. So I'm going to do x plus 8 times x minus 3. And yeah, I'm going to FOIL that, and I'm going to get x squared. Outsides is negative 3x, insides 8x, last with last is negative 24. Here are my like terms. So I have x squared plus 5x. Is it plus? No, sorry. Yeah, plus 5x minus 24. Now I have to come back and multiply that by that final term there. So let's go another level. We're going to take the 2x plus 1 and multiply it by this trinomial. And just like when you FOIL, you want to make sure everybody gets a piece of that multiplying action, so to speak. So I'm going to do piece by piece. So the first here with that one, and I get 2x cubed. And I'm going to take the 2x and move it to the middle and find that product, which is 10x squared. And finally, bring it over and share it with that last guy, and I have negative 48x. Now I'm going to come back and work with this 1 here, because I haven't distributed that yet. And again, I'm going to work it with each of those terms. So that's 1x squared plus 5x, and 1 times negative 24 is negative 24. And again, now it's a matter of combining like terms. I only have 1 x cubed term, so that'll go up front. And since they said we want this in standard form, standard form means you're going to write your final solution in sort of descending order of exponents. So my first one would be the cube term, because that's the highest one. And now I'm gonna cross it a little bit because I get distracted, and I'm going to look for the x to the second power because I'm going in descending order. And I have a 10x squared and 1 more here. So I get 11x squared, and those are done. And now I'll go on to the x terms, x to the first power. There's negative 48 plus 5. That's negative 43x. And all I have left is the number there, the coefficient. So this is in standard form because we're going from 3 to 2 to 1, right? Descending order. Problem 16 is kind of rough to explain. What they're looking for you to realize in this problem is that we're going to deal with the difference of perfect squares, or the difference of 2 numbers, so to speak. They're talking about this subtracting 1 comment here. What you should be thinking is, the reason that 30 and 29 could be thought of as 30 squared is because when you break it down, 31 times 29 could be thought of as 30 plus 1 times, no, I'm sorry, yeah, times 30 minus 1, right? This is 31, this is 29. And now it looks similar to like when we were doing the difference of squares, right? Because you're just going to do 30 times 30, that's 30 squared. The inner and outer terms are opposites, so you don't have to consider them. And then when we do the last one, then positive times negative, but we're going to square it, but it's going to be minus 1 squared. In which case, 30 squared is 900, minus 1 gives you the 899. So the idea here is Jeremiah, we're going to answer this properly, Jeremiah knows that a plus b, this form, something plus something, times the same pair of numbers with a subtraction, always works out to look like this. And because that's the case, that's where he went on to evaluate it by saying 31 is 30 plus 1, and 29 is 30 minus 1, and so on and so forth. The expression below can be written as a product of x plus 4 with another binomial. So for problem 17, we need to determine the other binomial. And when you look at this carefully, notice that both of these have the x plus 4 term as one of their factors. So I can rewrite this by pulling out, or let's consider it sort of like, think of, we're dividing out the x plus 4 from everything. When we do that, we are left with x plus 4 times x minus 2, the first one, plus, right, these are gone now, this came out to the front, x minus 2 plus x plus 7. This gives us, when we simplify it, x plus x is 2x. We're adding, don't FOIL, this is adding, addition. I know the temptation is to FOIL, especially if you are sloppy. Negative 2 and 7 is 5. So the other binomial is 2x plus 5. Okay. Problem 18 is somewhat similar to the one we just covered. We have to write the following expression as the product of two binomials. I'm seeing here before I get started that there's subtraction in this problem. The other one was addition. But I also see that both of them have an x plus 5 term. So this will then be simplified by one of the factors being x plus 5. I'm going to pull that out. And what's left is my 2x plus 11. But instead of plus the other term, this is subtraction. So minus x minus 2. Now, remember again, subtraction is like adding the opposites. And this is where I presume people will really fall into trouble, missing that you need to flip the signs. So I still have the x plus 5. But when I rewrite this other business here, I still have the 2x plus 11, but now it's minus an x and plus a 2. Okay, so here the x was positive and the 2 is negative, and notice how now the signs are different. Now I can just simplify it. Combine like terms, And there's my solution. Instructions for 19 are pretty straightforward. Remember that when you factor completely, and that's the issue here, not stopping halfway, that you want to, step 1, always factor out your GCF. So let me write that because that's always the first thing. And then you work with what's remaining and see how you handle that. In A, I see that one GCF in common to everything here looks to be a 5. Right? They all have 5, or in other words, they're all divisible by a 5. So I'm going to pull the 5 out, and when I do that, it leaves me x squared minus 4x minus 21. Now, this is where completely comes in because I'm not done. I have a trinomial here that I can further factor. So the 5 is one of the factors. When I factor trinomials, I like to set up my pairs of parentheses up front, and I immediately put in x up front because x times x is x squared. I'm thinking now of two numbers that can multiply to be 21, but they also have to add to equal that middle term. And that pair of numbers that works for me, I think, is 3 and 7. Right? 3 times 7 makes 21. How can I add them to get a negative 4? Well, the 7 must be the larger one. So, here we go. And that's my solution. In B, the common term to both of these, they both are divisible by 3. 3 is a factor, but they also can give up an x. So I'm going to pull out 3x from each of them. That leaves me with x squared minus 25. Well, here we have the difference of two perfect squares, which always take the same form. This is a no-brainer. So we have 3x, and that would be the square root of 25 is 5. So we have x plus 5 and x minus 5. In C, I have, this is a tough one, because now I have x to the 4th power here. So let me think how I could do this. Let's try this. I know that x squared times x squared can give me x to the 4th. Let's see. I know a pair of numbers that could make 36 and still add to 13 might be 4 and 9. What signs should they be to make negative 13 there in the middle? They should both be negative. There. And you can FOIL it to double check that you get the same answer back. There's my negative 4x squared and my negative 9x squared, and it works. But it says completely. Again, I have two pairs of things that are both difference of two perfect squares. The first one, take them one at a time. That would be x plus 2 and x minus 2. The second one is x plus 3 and x minus 3. Square root of 4 is 2. That's why I used it. The square root of 9 is 3. And I'm done there. For part D, I look at these and I see that they're all even numbers. So the first thing I'm going to do is take out my GCF, and it looks like the greatest common factor here is a 2. And that leaves me with 4x squared minus 5x minus 6. Now I have a trinomial here, but the leading coefficient is 4. In other words, a is greater than 1. So I'm going to use my payback method. So I'm going to keep the 2, and I'm going to temporarily take the 4 and remove it and multiply it over to the back end of the problem. Okay. The reason I do payback is because now I have something I can easily factor. And I know the pair of numbers that I can use to multiply to make a 24, but somehow add to make that -5 has to be a combination of 3 and 8. It's the addition part that helps me decide the sign. If I'm going to add them, the 8 must be my -1. So I'm setting up my factoring. I'm going to pop in my 3 and my 8. And again, checking, it has to add to be -5. So that must be the -1, and that's the +1. And here's where now I have to remember to pay back, because I'm not done. I took a 4 off early in the problem, which was illegal. So I have to remember to replace it back. And so there it is. And so finally, as I get to the last step, I just want to simplify this down. I have 2. 4x plus 3 can't be reduced, so that remains. The 4x minus 8, though, I could divide 4 out of that, like they're both divisible by 4, which would leave me then x minus 2. For problem 20, we have to consider areas of rectangles. And again, the area of a rectangle is always calculated by doing length times width. In the first part of the problem, we have to find the area of the larger rectangle. So looking at that, I have 2x plus 7 times x plus 3. And we're not getting a numerical answer. It says get it as a trinomial in the terms of x. So we're going to FOIL this. And that gives me 2x squared plus 6x insides plus 7x, last with last. And so the final simplified solution is 2x squared plus 13x plus 21. This is the area of the larger triangle. Let's get the area of the smaller triangle. Well, those dimensions are x plus 3 and x minus 5. And again, we have to FOIL or distribute. In this case, first with first is x squared. Then I get minus 5x for the outsides. The insides are 3x. And the last are -15. And so ultimately I get x squared minus 2x minus 15. Now we're asked to find the area of the shaded region, which kind of implies you're going to take the area of the large rectangle and subtract away or cut out this value from the center triangle or the inner triangle. So this is a subtraction problem. That would look like 2x squared plus 13x plus 21. That's the first one, the outer rectangle. And I'm going to subtract from it the area of the inside triangle. And again, don't forget that subtraction is addition of the opposites. And I've written it every time here. So I hope you remember this. So I'm going to take this and I'm going to rewrite it by flipping all those signs. Remember, we could consider, if this helps you, that there's an actual 1 here in front and you're distributing -1. And that's why the signs are all flipping. So what this looks like then is 2x squared plus 13x plus 21, and now minus x squared plus 2x, see I'm flipping the signs, plus 15. And so my final answer is x squared plus 15x plus 36. The area of the shaded region can be written as the product of the binomial x plus 3 and what other binomial. Show how you arrived at your answer. So we have to take this solution we just got, the x squared plus 15x plus 36, and we want to factor it. We already know that one of the factors is x plus 3. So all I'm thinking is 3 times what makes 36? And I think that's 12. And does 3 and 12 add to be 15 here in the middle, positive 15? Yes, it does. So I know this is correct, and the other binomial is x plus 12. We're on to our final review problem. More reinforcement of the skills we've been using. We have to simplify this expression and write it in standard polynomial form. That means, again, we want it in descending order of those exponents. So the highest exponential term goes first, and so on down the line. So we have a subtraction problem. First thing we want to do is FOIL each of them, so then we can go about the subtraction part. So working with 3x plus 2 times x minus 4, the product of the first with the first is 3x squared. The product of the outer terms is negative 12x. The inner terms is 2x. And the last with the last is minus 8, which gives me finally 3x squared minus 10x minus 8. Now I'll do the other pair. That's x plus 5 times x minus 4. No, 1. And again, foiling x times x is x squared. Outsides, minus 1x. Insides, plus 5x. Last with last, minus 5. Like terms in the middle, simplify it, and we get x squared plus 4x minus 5. This was a subtraction problem. Again, we're subtracting this second part from the first part. So let me write that here. 3x squared minus 10x minus 8 minus the second trinomial. And again, I'll say it. Subtraction is addition of the opposites. So 3x squared minus 10x minus 8. Now I don't want to do subtraction. I'm going to flip all the signs. Minus x squared minus 4x. And now that becomes plus 5. And I'll combine like terms. From the highest exponential term first, because we're writing it in standard form. So 3x squared minus x squared is 2x squared. Let's cross that off of our thinking. It's done. Let's go on to the x terms. Negative 10x, negative 4x. Together, that's negative 14x. And I have that done. And finally, I have my numbers. And that's just minus 8 or negative 8 plus 5, which is negative 3. And we are done with our unit review. Thanks for watching.